Hello everyone, welcome to another live stream. Give me a second. I'll be right with you.
Hi, Chad.
Okay. See, I told you I'll be right with you. Hi, the Remco. Hi, the Presmo. Hi, Nedland. Hi, Mega Techno YT. Hi. Hi, Eddie.
Hi.
Oh my goodness.
Well, I haven't done anything wrong
Yeah. Yes, I agree. The weather is crazy. Hmm? You get this with a voice changer?
yet. Me?
No. I was talking to myself actually.
I haven't done anything. Wait, what was... fuck. If my mic is broken.
I think it might be. You sound.
As far as I know, this is the connection. And I hope so. It's only the USB-C connection.
Yeah, I don't know exactly how broken it is, but that doesn't sound like what the microphone is supposed to sound like. Join in the Maker Dream. Hi, the Theophanic. Hi, welcome. And today we will be. Hold on, let me open it up. Which file was it? Which file was it? Which file was it? There we go. I think that's the file. We'll be walking on a quantum field theory video, everyone. Oh boy. Lovely. Wave function. Technically, this is the wave function one. This is just like wave function. This is actually quantum field theory. The next one is the wave function, which is this one. The current one. The current one is the next one. Do I have page down? Oh, I do have page down. My keyboard is comically small, so. Wave function. Lovely. Now, for the wave function, just a random paper in my sources. Number 12.
Yay.
Oh, you're
Hello.
fixed, Nitty. You're fixed.
I'm so happy. My mic isn't falling apart.
I don't understand quantum physics by Douglas Ross. How did I even find this thing, actually? Because I only have the collapse linked. That's a good one. Remco, how to join your voice chat. Okay, hold on. What should we do? I don't want to use. I don't want to play trash from someone. We might use it as a supplementary source, but for the main source, we're going with the classic. Plural, yes. We're going with LibreText. Oh, wave function is gonna be. I don't want to explain the Schrodingers for it, but I might have to. I'll explain Schrodingers for it. Is there a way for me to explain the wave function properly without explaining the Schrodingers? I love when scientists are honest. I know a single person who actually understands quantum mechanics. I do. That's Remco. That's what Remco's there for. Remco's there specifically to understand quantum mechanics. Remco is that one guy who understands quantum mechanics. There's only one. At any point in the universe, there's only one. environment of having all information about the state. I mean, yeah, I know, I know that much, but I want to explain it properly. As in, actually, this is gonna be a whole video just about the wave function, right? I'm not going into operators. I'm not going to any of these. I'm just going into the wave function. No, this ain't it. Is it? Ooh. Or is it? Okay, so this is nice because it's transitions from physical experiments to mathematical description, which is neat. That's certainly neat. That looks like a meme. Alright, what's this one? Oh, this is just wave particle duality for... That makes sense. Plane waves, I guess, would be useful. Describe it with... But I don't need the Schrodinger. Yeah. If you want to explain it properly, you're gonna need the Schrodinger equation. Yeah, I guessed. Quantum Mach physics, my favorite, dinner. Let's do for wave function, because I'm pretty certain this one started with... Or that's the wrong textbook. Okay, no, that's the mathematical template one. Schrodinger's equation example systems. Well, boy, that sounds kind of useful. Simple harmonic oscillator I should also chuck in there, I guess. I haven't chucked in this simple harmonic oscillator. Jeez. Louise, more, I'm behind the explanation. Because how are you gonna explain the wave function without mentioning how they behave? Exactly what I'm saying. These symbols, they scare me. They're not scary, actually. It's just that quantum physicists are just allergic to normal notation. I'm sorry. That quickly, huh? List for the postulates, that's nice. We could approach it a bit mathematically. No, but for that we need background. No, that's for the future. But even though I know it may seem counterintuitive to leave the postulates of quantum mechanics for the future, but trust me, it's a process, right? Oh, and the harmonic oscillator linked as a source, because of course. Okay, hear me out. Hear me out. Are you hearing me out now? Just hear me out. What website is this? This is LibreText. The one, the only. Exactly, Rainspec is correct. It is the one, the only. The myth, the man, the legend. The behavior of states entirely determined by physical main classical mechanics and SE in quantum mechanics. So I guess Schrodinger's would be in this. Nabla? No, not Nabla. Not Nablas. Nabla squared? No! Periodic solutions can be written in the form this. Total energy is the sum of kinetic potential energies, and the kinetic energy is because not realistic from you can judge it as a calculation of when right to what extent is justified if you instead of p substitute the Broglie expression in the form of equation you arrive at Schrodinger's. Okay, yeah, so Nabla side. Oh, you can just check the Nabla onto the other side. Oh, this on the other side is usually, I do believe, how they do it. 2m divided by h bar squared, which is kinetic minus total energy. No, wait, total minus potential? Oh yeah, potential, never mind, that makes sense. Wait, you about Quabla, that's not a thing, you're just trying to scare me. I refuse to believe that's a thing. No, that's a thing. That's no. Why? No, and you like wondering why everybody hates advanced physics. No. No. Absolutely not. Actually, it isn't all that bad. Now that I see it, it's actually not too bad. I mean, there's a lot of partials, of course. It's I mean, I'm assuming this is relativity in all cases, just curvature on each of the respective in each respective dimension, isn't it? It's nabla squared, okay. It's not that bad. It could be worse. Oh my goodness, I'll have to understand what nabla is actually. But yeah, I don't understand nabla. I don't even understand how nabla works. Because I'm not at that level of linear algebra. I called it, yeah, incorrect triangle. Nabla was named after the you know what? No, we're not getting on the tangent. Calling it quabla is much better than calling nabla something. It's affected as partial derivatives entries. Yeah, but you know, I need the physical meaning behind it, because you know, because I ain't gonna just say that in the video, Remco. I need the physical meaning behind nabla, or the interpretation of nabla. I need the what it does, what it do, what it be doing. Oh, Maxwell's would be a good start for nabla actually. Hold on, Maxwell's equation, I think that would be good. Well, that could be actually a good starting point for understanding nabla. Yeah, because I think this is a pretty good example for nabla, right? The unit vectors. Okay, so we take the unit vectors, we multiply them by the partial derivative on each axis. Okay, so I'm guessing the unit vectors are for each value, each axis. And why do we do unit vectors? Well, it's because I'm guessing because it's because stretching that would be even more, wouldn't it? Measure the rate of change in all directions. Wait, why is it multiplied by unit vectors? The quabla doesn't multiply by unit vectors. And the quabla is a squared nabla. To make it a vector. Oh, I see. Then never mind. Then, okay. I honestly thought there was more to it than that. That's simple then. Quabla is not a vector. Wait, you can just take... So hold on. You mean to tell me that you can just take... Isn't this a scalar? Or am I an idiot? Isn't this a scalar? Well, ish. You know, you get what I mean. Single dimensional. You can subtract from... You can subtract the vector from a... So you can take a scalar and subtract a vector differential from it. Actually, did make it ever explain multivariable calculus stuff like partial derivatives? I mean, partial derivatives are really simple. I don't think... Honestly, listen, call me a conspiracy theorist if you want, but I don't think there's any difference between derivatives and partial derivatives. I think it's just one big conspiracy. The x, and then you have the x, or dy, I guess, dx, and then f of x and a. Like, call me a conspiracy theorist if you want, but I don't think there's a difference between derivatives and partial derivatives. Dual vector or covector difference between partial no derivatives, implicit derivations. No. There's no difference. There's no difference. Partial derivative. More like. Imagine I said something clever there. Yeah, that's sour. Now, why am I focusing on Quabla? Might make it stop fucking. It's implicit, you heathen! That's good. There's no difference when you get to thermodynamics. I feel I've got. Reblax would have tore my head off by now. I'm glad. Yeah, that's good. That's good. I'm glad back to physics, you know. My brain feels kind of cold right now. Well, I'm welcome to the club. I'm there as well. Okay. The pickle of Schrodinger's equation isn't the meaning. The meaning I've explained like months ago. The pickle is that this time we don't only need the meaning, we need the interpretation. Therefore, I genuinely think Wikipedia might be a good source for this, actually. Because, if I'm not mistaken, it has all the variations, all the variants of the Schrodinger. Like, yeah, the Hamiltonian and so on and so forth. All them energy stuff. There we go. Them's the one. And I'm pretty certain this is just this with the energy carried on to the other side. I think this is energy, right? Even in physics, a very open and respectable level. A very open and respectable level. The Reblax would have told your head of this time. Kinetic energy. Yeah, so this is energy, this is kinetic, this is potential, right? At least that's how I read it, because this is just potential is V. I remember that much. So hold on. Yeah, kinetic potential, and this is just E. Wait, E is total energy. Sum of the kinetic on potential? Oh, because it's swapped, that makes sense. So if we chuck this onto the other side... Not black hole. Hold on. Oh, because it's single dimensional. I'm an idiot. You need to give me a second, alright? You need to give me the second because I'm a bit slow right now. It's single dimensional. Confused me a lot. I am pro of introducing another type of energy to fuck up the universe a bit more. The physics way. Sting energy. Oh, I've never heard of sting energy. Is it real or did you just make it up at the spot? I don't think it's in the carbonated energy drink. Okay, well, close enough. Okay, so what was I doing? Yeah, right. This, which the broccoli. Actually, let me just get the Reblax. Can you pronounce the broccoli, by the way? Like, can you pronounce the broccoli? You know, this one. Where's the broccoli equation? Remco, you Remco. I'm sorry, I'm just mathematics. I've been dipping too much in mathematics recently. I'm gonna be confusing you both. I call him the broccoli. Yeah, because that's what it's called, isn't it? The broccoli. No one can spell it and no one can pronounce it. There's not a single person in existence. If you think you can pronounce the broccoli, then you're just lying to yourself. That's the way everyone watching right now. Reblax is making a gamble with the maths game video. Maths game video. The broccoli. The broccoli is much better. Right, so wait, 7 what now? 745. No, 773. Okay, 773 is this one. So momentum is h bar k. It's momentum, right? Let me just double check. Has to be momentum because that's the only thing that makes sense with the H bar. The units have to, you know, stick together. I can't drop it. I need to make sure it's momentum. The broccoli was pretty sure like broccoli. Oh, I hate to ruin the fun, but unfortunately broccoli doesn't. I'm pretty certain it doesn't have a wave. Broccoli just has a bunch of things on waves. These are veggie happiness by studying some broccoli wave functions. Broccoli has a lot of stuff with waves though. It's actually funny because the Broglie isn't one of the like main culprits when someone thinks of quantum mechanics. You know, Planck, the name of Planck gets thrown around a lot, obviously. But he did a shit ton. Like, oh my goodness. Page by K. Okay, K squared. So if I'm not mistaken, it would be, and pardon my French here, K squared is equal to P is equal to H bar K. Therefore, K is equal to P H bar. I see the problem because when you square it, you get H bar squared and P squared. And then that's pickle because 783. So this one. Wait, where'd you get this from? If you substitute the Broglie expression in the form of instead of P. Please tell me it's a unique name. Please tell me it's different from Broglie equations, masses, when Vegas. No, it's damn it. Hi, the Red Blacks. Maybe I was making to make a new math video. I'm working on the massive math video. In the background, okay, linear algebra. I'm still working on this. It's really big. Big video. Big video for the big boy. H new. I guess you could, yeah, because I guess you could get it from new. From P more. Wouldn't it be from P? K squared. Okay, so you can substitute with P squared H bar squared. Partial normal derivatives are identical. No, I feel comfortable saying it without Roblox here, right? I'm just saying that it's a liberal conspiracy. It's a plot by big maths to sell more math characters. No, it's a liberal conspiracy. It's the same as physicists inventing new dimensions. It's the same thing, except mathematicians do it for characters. Like they want to pretend that partial derivatives are different from just derivatives. It's real. Yeah, it's a real thing. They're not different. They're the same thing. It's like I mean, come on. Partial derivatives definitely. Yeah, right. You would say that, you mathematician. Do I even need to go in depth about how it's made? I don't. I don't need to, actually. We can just start with it. Because honestly, this already tells you everything you need to know. If you swap it to the other side, switch to live chat by the way. Oh, thank you actually. I completely forgot. There we go. Hold on, because this is actually the nabla there is just, it's like, I get why it's, I understand now why everyone just does it the one-dimensional example, because I mean, it's because the mathematics make it. I feel by the raging conspiracy of liberality. What can I say? I'm just the. No, I'm against the big scams. You have the big carbon of chemistry, big characters of mathematics, and big dimensions of physics. I guess we just carry negative to, yeah, whatever. Plus, minus v. And then psi. So, if I'm not mistaken, then this just says that the wave function changes based on the energy. I need more than that. Do I need more than that actually? Wave function changes based on energy. I mean, kind of it. I might leave the actual explanation of how to build to Schrodinger's for another video. Because I mean... because I mean, I'm gonna finish this video in probably 5 days or something, so... Christian DC, I'm not into no France lover. That's good. Good start. Well, the Inter part, you know, it's not relative, I guess. Oh, so please explain what you're doing. I'm research. I'm researching. One of these ones had a pretty neat explanation of. I'm pretty certain this is Euler's classical lightweights. One of these had a very neat explanation of how to get to the wave function from Schrodinger's. But I don't remember which one. It might have been not Fowler, not Fitzpatrick, only the Valet. I think that's how it's pronounced, I don't know. Hi, The Mix. Hi, welcome. Right away? Just, okay, well that's quick. No. No. The Harmon of the oscillators, the chapter 7. Okay. Which one was it? It could have been Fitzpatrick, but because there was one way when they like, was it quantum theory of light? It might have been. Let's just go through the Fitzpatrick one and see. No, this is the basics. This is the basics. This is the experiment, right? This is the 1% probability. Big P. No, classical particles, quantum particles. The slightly different rules still mean the same thing. Got it. Wave packets. Okay, so. What are you searching? I'm searching for how to build to the how to build to the wave function from the Schrodinger equation. Like this actually, this right here, this animation is kind of what I'm looking to explain. This This is this will be kind of the point of the video, explaining this. I don't know if the if the complex wave function will be required there. I think I'll more do it like. I think I'll do it more like, I don't know, just a region of space, just with brightness representing probability rather than this, but this kind of expansion probability thing. Propagation phase velocity. We've seen the phase velocity is only half of the classical velocity of a massive particle. From before, the most reasonable physical interpretation of the wave function is that the most reasonable physical interpretation of the wave function. Yes, the concept that you completely invented, and right now you're looking for a reasonable interpretation of it. You know what? I'm fine with whatever. See Wicca. Is proportional to the probability density of finding particle position x time t. However, the modulus squared of the wave function is this, which depends on neither x nor t. Or in other words, this wave function represents a particle that is equally likely to be found anywhere on the x-axis at all times. Hence, the fact that the maximum minima of the wave function propagate at phase velocity does not correspond to classical particle velocity. It doesn't have any real physical consequences. Wave function does not correspond. Particle velocity does not have. We didn't find the wave function. The wave function found us. Okay, hold on. So, proportional to the probability. The modulus squared of the wave function. I would really like the link there, actually. Because this is modulus squared of the... Oh, and the Fourier, of course. Wave packets, right, that seems important. There we go, this way. Okay. Wait, what? Modulus squared of the wave function. Bar. Jeez, I hate this notation so much. Because bar... Yeah, like right here, this is a constant. If I'm not mistaken. This is normalization constant. And right here, this is a function. I think this is in, oh, was that in a different textbook? Hold on, I gotta find it now. Damn it. Wave path duality, if I'm not mistaken. Oh no, wait, that was sinol. That was sinol that I was thinking of. That was sinol. Yeah, never mind. Sinol and sidebar. Just, you have letters! Letters exist in the... Okay. So this is the... What? Fourier? Of the wave function? However, the modulus squared of the wave function is... So this is the Fourier one. With my minimum background math, I hate how physicists do physics. Making discovering that physicists like to never write explicitly when stuff is a function. Oh, I was aware already. It's fucking lovely, you know? Because why would you ever need to know what you're dealing with? It's a character. Oh, what is that character? Is it a scalar, a function, a tensor, an operator? Who cares? It could be a fucking, I don't know, group or Wicca. It could be a knot. I wouldn't know. Alright, so this is the Fourier wave function. Right? I'm pretty certain this is right. Let's go from the combination playing with different number was. Alright. So we need 10.9 for the particles to understand it better. Was extremely on the behavior of non-resident particles, not your mass, electrons, and absence of external forces. So guys, can I say something? My goodness. So this is a quantum mechanics textbook, not quantum field theory, but whatever. That's good. There's still good basis still needed. Quantum particles. Right, same relation of the Broglie wavelength. Okay, so this is just the basics of them waves. Lovely. Wave packets. So okay, is equal to okay, so if the wave number is greater than 0, all right, and the time equivalent of the wave number, if I remember correctly, is greater than 0, which, you know what, I would say that's fair. That's a fair requirement for a wave. Link via dispersion relation, which was the probability. That's the same chapter. Oh, that doesn't link to anything. That's cool. Expression represents maximum manipulation in the positive x direction with phase velocity. This okay. Function is this. However, the modulus squared of the wave function is this, which depends on k. Here they just assume everyone's clairvoyant and omniscient. Okay, so the wave function, is it because it's which depends on neither x or nor k? Okay, I get it. This is simple. This is simple. We get the yeah, okay, that's, oh my goodness, that's trivial. You know what would make this so much easier? If instead of writing down fucking this, hold on, let's, this, okay, if instead of writing down this, they would have wrote down this. Because this shows much better that it is a function that's not dependent on x or t. But you know what? I'll take it. Okay, so it makes sense. The Fourier wave function, dependent on the wave numbers. Oh wait, is it dependent on k or k and omega? It might be both. I don't know. I don't know. I don't know because it doesn't. I'm fine. I'm fine. I'm not upset. I'm fine. Trivial. Direct standing around this grave. Okay, I'm fine. So this makes sense. Corresponding path to classical particle velocity does not have any real physical consequences. How can we write the wave function of a particle that is localized in x? That is, particle that has more likely to be found at some position on the x-axis or the others. We can achieve this goal by forming a linear combination of plane waves of different wave numbers. Or in other words, we add together. Oh, this is fun. Yeah, I'm gonna have to do some make it trickery there, won't I? Okay, Desmos. Because this is something I actually have to hide the flame. I can't hear you reply. Cool. Mathematicians and especially physicists are lazy writers. I like how you say especially physicists to include them in the thing. Okay, cosine of kx, just for the sake of it being simple. Looks like this. Now if you take the integral from negative infinity to infinity of this function, dk f of k, you get the 0. That checks out. Makes sense so far. No, wait, I'm doing k multiple times. Fine, let's do a t over here for the sake of absolute complete confusion. Okay, this checks out so far. However, what we do then is we multiply it by the Euler. Which, well, what I always do when I find myself with a complex Euler in an integral, which, believe it or not, has happened to me on multiple occasions in the past, then for the sake of understanding it, I have to break it down, which means we don't care about multiplying it by this. Let's do cosine x, because it's kx minus omega t. We don't care about t yet. Ooh, Desmos might struggle with this one. Yeah, Desmos might struggle with this one. Okay, so 0 multiplied by the number. Wait, isn't it 0 by default? Oh no, it's undefined actually. Cool, it's also in between 0 and undefined. Wait, cosine of x. So we're taking the waves. We're taking the changing waves. Oh, but the k also changes in them. Wait, what? Hold on. Wait a second. Wait, no, this doesn't make as much sense as I thought. Is it inverse Fourier? Is it? I fingers crossed that it is. 2 pi I. Oh, yeah, no, this isn't fx. This is the Fourier one. All I'm looking for is just. I mean. Inverse Fourier of a Fourier is equal to function. Yes. But which one is the inverse Fourier? Good night, Nerdland. Good night. Good night. Have a good one. Inverse Fourier, where's the inverse Fourier of g? Okay, of gx is this, which is g epsilon the epsilon. That checks out so far, and then e I kx screwing me over x times this. This would be an inverse Fourier, correct? That's a question. It's a question mark there because I don't actually know. All right, going back to quantum interference of light. No, going back even further to classical interference of light. Hi, the timing. Going back to quantum theory of light. Going back to the photoelectric effect, going back to classical light waves, going back to representations of waves via... Oh, never mind. Next one, classical light waves. Yes. It's just equality. Yeah, you see, I find that... Oh, is that the difference between classical and... I'm gonna lose it. I'm gonna lose it. Okay, so the this is classical. Hence they mean different things. Correct? Complex wave function. What's this then? What's the sidebar? I'm sorry. Am I going mad? On this isn't sidebar. Like, this is the definition we should follow. I'm gonna lose it. I'm gonna lose my marbles. I'm going to. So what is the psi bar? It's the idea we have the complex wave function, complex wave. Oh, that's on the right. This. What's this? The psi bar is where physicists go to get drunk. Get out of here. No, I'm losing it. Okay, minimize these two because I'm losing it, and let's just quickly go for the Fowler. Not harmonic oscillator on the. Oh, mostly one to quantum mechanics, yes, okay. Okay, maybe not. Change my mind. Let's go to. Introduction. Why not? Okay. Wait, no, that's not what I mean. The second. Concepts from classical mechanics. Okay. Conservative field energy function, simple example. I'm gonna take your word for it. Schrodinger equation. State of a quantum system, why not? Position, velocity, spin. Okay, cool. Probability density, the entire probability density has to be 1. That checks out. Then some probability stuff. Here I am lazy and use the lowercase x or I. I've used x for the standard practice in quantum mechanics. Gosh, this. Aspects of classical waves and see whether they can help exist or derive probability density from a wave equation. Being lazy standard practice. Subject because you derive probability density from a wave equation. Standard example of classical wave is the motion of a string. Typically, a string can move up and down. Solution to the wave equation, we have this. Okay, so. Okay, checks out. Wait, does it? Solution to the wave equation. Does it check out? So the derivative of. Wait, so the curvature derivative. No, what's the formal name? So like the acceleration and such is equal to 1 divided by speed of light squared times that. Sorry, what? Positive versus negative. Oh, that's what. Wait, that's why. Argue what wave function describes the quantum analysis of mechanics as a propagating wave. Set of wave problems is given by a plane wave. A and the real part of Euler. A wave propagating in the x direction with wavelength this frequency, we interpret the plane as propagating as a propagating beam of particles. Probability as the square of the wave function is not very sensible. We'll take the real part of the exponential. It will probably be oscillating with a complex function, right? However, the probability defined as the absolute value squared is a constant a squared. independent of x and t, which is very sensible for beam particles. That we conclude the wave function is complex and the probability density is. I actually like this textbook a lot. I'll be honest. I really, this might be my favorite one. I like the bread, Theo. All right. We find this and this and this. Generalize classical mechanics. Characterize the ratio between moment and energy. All right. To the quantum realm. Notice that the momentum is equal to h bar this, which is equal to h bar divided by I. Derivative in relation to x. Yes. Yes? Yes. Okay. I think so. And then energy goes this way and it gives us this. We can, using this, we can guess a wave equation of the form. This is, by the way, the first time I've seen this. In the Fitzpatrick one as well, it was like, it is now a reasonable guess that the energy operator will take the form of. And I mean, using the definition of energy informs the currents of potential. Okay, so one over 2m h by I. Okay, so 1 divided by 2 masses of momentum. No, because it's okay. So 1 divided by 2 masses and then derivative of position relation to time, which I'm pretending. Okay, I don't know if that makes sense. Then that is equal to the energy. Okay, does that make... I mean, that looks like a Schrodinger's, but let me think for a second. Rebux, I heard somewhere that to be a good mathematician you have to be lazy. No, that was a programmer or a computer scientist. Are we taking this? Well, it's because the momentum... Wait, what's momentum? Momentum. Momentum. There we go. Kilograms meters per second. Kilograms meters per second. Meters squared per second squared, wouldn't it be? No, it has energy. Wait, how does it? Using this, we can guess a wave equation of the form. How do you guess it? How? How do you guess that? What steps? Hold on, I just zoomed down for a second. The computer into having such as EU accommodations. Isn't there a better proof? Imagine you are carving each sentence into stone. You don't want to elaborate, but you want it to be correct even in 1,000 years. Oh, that's a really good one, actually. I like that. I like that a lot. That's a banger quote. How can you guess that wave? I'm losing my mind. Time independent Schrodinger equation. Okay. This equation initially we understand the time independent Schrodinger equation. The probability is independent of time. In order to simplification, we must find of the form of this. Okay. Time independent Schrodinger equation. So this. My professor said, don't bother with proofs, just walk to the math department around the corner. That's also a powerful one. Okay. So now that that doesn't make any sense, we can move on to the Hamiltonian. Which is just based on that, based on the previous drawing. Okay, good. Schrodinger's equation is its linearity. For the time-independent Schrodinger equation, which is usually called the eigenvalue problem, the only consequence we shall need here is that if it's an eigenfunction, the Schrodinger equation. Yes. I'm losing my marbles. We're tired as of now, but last message got more and more unhinged in the silly way because he just could. That's powerful. Really is. You know what? I think that might be it for this stream. Every single one of these learning live streams is killing me. They take a lot of mental effort, which I'm not ready for. Why did you guess that? I'm losing my mind over this. No, I can't embrace this. That's how I learn physics. But how would you jump from, where is it? These two to this one? How do you jump there? How do you make this connection? From these two, piss off, piss off. From these two to this one. I don't know. Someone guesses before and you are copying them without citing. Well, that's bullshit. Damn it. Damn it. Oh, don't tell me I need to go into the rabbit hole. Drugs. Yeah, no. No, I can't. I need to go. I need to go on a long walk to think about my life choices, you know? And I'm going to. From basic knowledge of one theory. About the energy! How do you get the energy? Because this is about energy being... basically switching up the momentum to be equal to energy, right? No, I need to go. I can't deal with this. My video isn't performing well. It's actually one of the worst videos I've uploaded in a while. I'm going. That's it. I'm done. I'm done. I'm done. It's over. I'm done. And for now, I suppose that'll be it. Thank you so much for watching and have a great day. Bye.